Decay. All right. Okay, so I'm going to give you a log equation, and I want you to write it as an exponent. And then I'm going to give you something. I'll give you the page to work on, and you just do those problems, and then we move on to the next topic. Does that make sense? All right, so if you had something like this, if I had something like this, in order to write it as a logarithmic equation, you want to flip-flop the whole equation to make sure the log part is on the left side. So you're mathematically not changing a thing to the problem. You're just using the associative property so you could flip it over. Is that good so far? And then what you're going to do from here is you start at the base. So this is read as log base x of 7 equals 5. So you start at the base, and you do kind of a seashell. So this becomes x to the 5th power is equal to 7. Okay? Does that make sense? So first thing you want to do is you want to make sure that if it's given to you where the log is not on the left, you flip the entire equation over. You don't change any signs. You just flip the whole thing over. And then you start at the base, log base, and you shell it around. Okay? So on this sheet, I want you to work on the first 4 problems. 1, 2, 3, and 4. Oh my gosh. 1 and 2, and 3 and 4. Sorry about that. 1 and 2. 1 and 2 and 3. Yeah, I'm going maskless so I can actually hand out papers. 1 and 2. All right, so try the first 4 problems, and then we'll go over them. You have until 2 o'clock to get the first 4 problems done. Recording again? So I'm going to write them up here. I'm going to already have them flipped over. So I just flipped them all over. Is that okay? Agreeable? So we start at the subscript, so base 2, so we do this. Start here, come around. Start here, come around. Any questions? Come on, Josh. Tomorrow. Yeah. Any questions on those? So it's stuff you've probably seen in Algebra 2. If you had me, you definitely saw it. Okay. So now what we want to do is we want to start solving. We want to start solving for the x that's given, okay? Can I move up the screen? Okay, so let's say we had log base 3 of x equals we'll make it. Let's say we had that as a problem. So I want to solve this. So I'm going to go this. So I'd get 3 to the 5th is equal to x. And on a calculator, you could do 3 to the 5th power, which is something. So x equals 243. Okay. So go ahead and try 5 through 8, and we'll take that to 207. Try the next 4 on there, and we'll take it to 207. So those problems, so the first thing you want to do is do this. So I get 2 to the third is equal to x. 2 times 2 times 2 is 8. You get that? This problem, we're going to take this around. So I get 4 to the negative 2 is equal to x. Ooh, 4 to the negative 2 is 1 over 4 to the second, which is 1 over 16. Is that okay? Number 7, we have log base 8 of x equals negative 1/3, which is going to be this. 8 to the negative 1/3 power is equal to x. So that's the same thing as x equals 1 over 8 to the 1/3 power. And then you have to realize the 1/3 power is the same thing as the third root. So I get the third root of 8, which is going to come out to 1/2. And then number 8 is like this. So this is going to be like that. 25 to the 1/2 power is equal to x. The 1/2 power is the same thing as the square root of 25. Square root of 25 is 5. Okay, now, there are certain rules of math that you might forget. Makes you normal. So what I want to do is I'm going to bust up and have Desmos. The nice thing about Desmos, as soon as you have an equal sign in a problem and you're trying to solve for something, you can go ahead and solve it by Desmos. Okay? So if you go and you graphed go to Desmos.com, our friend, graphing calculator. So if I look at number 5 and I wanted to graph it, I'm going to graph the left side by itself. So I'm going to go y equals. And then we have to look, how do I graph log base 2? I'm going to go into functions, see what's there, stats, distribution, miscellaneous, log base A. So log base 2 of x. And close your parentheses. And then the other side, you're going to go y equals 3. And notice on Desmos that they two intersect each other. You're looking just for the x value. So the answer to that one was just 8. So that's using Desmos to pull out, say, hey, here, this is what's going on. So it's a matter of you recognizing where to find things. Like number 6, I can do the same thing on. So again, on Desmos, bring up the keypad, have both sides y equals. Go to functions under miscellaneous, find the log base A. So I have log base 4 of x, close parentheses. There's our first equation. And then y equals negative 2. And again, you take a look at it and say, okay, if I click on the intersection, I'm looking just for the x value. So the x value of that one is 0.063. What did I originally get for an answer on number 6? What did I put on my board? Number 6, I had an answer of 1/16? Is 1/16 the same thing as 0.01 or 0.063? I don't know. Tell me on a calculator. 1 divided by 16 is? Anybody? 1.0625. Okay. 0.0625. Do you see how they got the 0.063? They rounded it. Cool. And then let's just make sure we got the other one. I'm feeling good about it. So each side is going to be y equals log base 8 under functions, log base a. So that's going to be log base 8 of x. Oops. And then my second equation is y equals -1 divided by 3. Again, you're looking for just the x value. And I think that one had an answer of 0.5. So that's just really what you're going to do when solving the equation. So what I'd like you to do is this. On the sheet, using Desmos, you're just going to take a look at the graphs. So I'd like you to do 13 through 18. And then on Desmos, notice they have ln, that's natural log. Natural log is going to be on the functions as well. Just take a look at the graphs, what they would look like. And let's see which other ones you want to do. That should be good. Take a look at 13 through 18 using Desmos, taking a look at the graphs. Make sure you familiarize yourself with the graph. And we'll do it again in a few minutes. Bring up Desmos. So number 13, you just have y equals functions, log base a. That's going to be a 3 down there. And let's see, can I move that? 3 to the x. So that's basically what the graph looks like. So what is that graph doing? You remember the term that was used about a year ago? We just have to be in quarantine for 2 weeks because we want to flatten the curve. So you notice how this grows quickly? That's what we were trying to do. Is we were trying to change the slope of the line from being a really big slope to approach to get our slope of our line to be in 0. That was the flatten the curve terminology. A lot of people are like, flatten the curve means COVID doesn't happen anymore. No. It just basically means that our resources that we have available are able to keep up with the demand, right? So that's your flatten the curve. Number 14 is log base 4. Just clear that. So I'm going to go y equals functions log base a of 4 x. Oops, delete. Oops, I forgot the y equals. That's my problem. So again, still looks very much the same. Flattening the curve is what's taking place. So that's essentially how you walk through all those. The natural log ones, just so you know and be aware of it, you go y equals, go back to functions, and find the ln, which is right here. And they just have ln x. And again, the natural log curve and the log curve, they very much are very similar looking graphs. They're supposed to be. Okay? So that's what we're going with. Now, there is there is a problem with exponential growth and exponential decay. Okay, right now that's a growth situation. But let's talk about something that might be, let's graph y equals 3 times 1/2 x. Okay, so this kind of graph is going to look very similar to this. I have something called an asymptote, which is going to happen at the x-axis, okay, because there was nothing added to it. And then if I wanted to figure out a couple points to plug in, I could plug 0 in. I go 0, 1/2 to the 0 is 1. 1 times 3 is 3, so I get 0, 3. And then sometimes you might want to do this where you're like, hey, let's plug a negative number in. Let's plug a -1 in. If I plug -1 in, I get 1/2 to the -1, which is equal to 2. 2 times 3 is 6. So -1, 6. So this graph looks very similar to this. Now let's talk about a few things about how this graph works. You all have heard that there are some people out in the world that they do drugs, right? Ooh, no. Right? You've all heard this? But then you've also heard there are companies that when they hire you, they have a mandatory drug test. Agreed? So, let's say we have a certain drug. I'm not saying what drug it is, but this is 1 month, 2 month, 3 month, 4 month, so on and so forth. Okay, and then 0, you're starting from 0. So let's say you have an individual who's like, hey, I did this drug. So this is when they did the drug. So in their system right now, there are 3 micrograms of this substance. So this is 1 microgram, 1 microgram, 1 microgram. So that's 1, 2, 3, 4 micrograms. So they're at some scenario, they decide they want to ingest a drug. And they're like, oh no, there's a company that needs to do this. Well, the drug test to test for something a month out is a very inexpensive test. So let's say you are trying to get into the FBI. The FBI is part of the federal government, agreed? Federal government has a lot of money. Why do they have a lot of money? Because it's based on the taxes that are taken in by all the people throughout the United States. So they got to spend other people's money. That's easy to spend, yes? Mom gives you a $100 bill, says, hey, I need you to go to the store. There was no change, right? So let's say we want to get out here. Let's say we want to get out here to 7 years. Me. Is this Uncle Freddie? Uncle Freddie? Guess not. Who's Uncle Freddie? I don't know. All right, so let's say we're going to go out 7 years in this situation. So let's do this. 7 times 12, help me out. Was 4, okay, to 1. It's 84 months. So I'm going to take this out. I'm going to make that 84 months. So 3 to the 1/2 power raised to the 3 times 1/2 to the 84th month, which is 7 years out. Again, FBI has a lot of money. They can spend other people's money with no problem. So we're going to go 1 divided by 2, which is 0.5. We're going to raise 0.5. We're going to raise that to the 84th power. That becomes an extraordinarily small number. But I'm going to multiply that number times 3. And it's going to give me an answer of this. Which means 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So this is how much of the substance is in your system. Someone went to a party. They did a substance. Not saying what it was. But now they want a job at the FBI. So again, you go get your job at local job that says, hey, we drug test. This test is going to cost about $2. This test way out here, this is going to cost tens of thousands. Yes. Right. But here's the thing that's scary. You want to say, hey, I want to make sure that drug's out of my system. So you have that in your system after 7 years. Thank you so much. Oh, sure. So here's the scary thing. A couple things. If you're going to go work for FBI, CIA, NSA, any of the big security firm companies, one of the first things they're going to do is you're going to sit down and they're going to strap you to a chair and they're going to give you a polygraph. They want to see if you're lying. Now, 7 years ago when you was in college, you wanted to try something. Not saying what it was. You thought you would try. And while you're in college, after 7 years, you're out of college, you got your master's degree, you're like, man, I'm going to get hired for the FBI. Now you're sitting in this chair, and they got a thing that comes around your waist, thing on your head, thing around your ankle, reads your butt cheek clenching. I mean, I'm serious. This is what these polygraphs are. They got all these things. And you're going to sit down, and then they're going to say, is your name Chris Stirrup? Yes, it is. And they mark when they do the question, and they see that that's the truth. I mean, they know my name. Now, if they see some spike going, got a guy named Chris Stirrup, everything on his application checks out, but it looks like he's lying about his name. That's not good. But then they're going to ask you some other questions that are pretty simple. Today is Thursday. Yes. Have you ever lied to your parents? Yes. Okay. They're looking for things that they know got to be a truth. And then they're going to say, have you ever used drugs? No. Now, some people think the faster you answer it, the better off it is. No. Some people think, oh, if we're going to wait and draw out this answer, it's going to be better. No. Because you're going to get a reading. So now they're going to realize they're going to disqualify you from working at one of these positions if you have ever used drugs. So if you answer yes to the question, you're disqualified. They don't want you. Certain drugs. And remember, we said it was a certain substance. We don't know what it was. We ate alligator teeth. It was good. So the thing is, they know. They know. So like things that will disqualify you, if you answer yes, have you ever used drugs, this can disqualify you from being part of this organization. If you answer no, they're going to probably see that you lied, and then they're going to take you into a whole separate room and sit there and ask you all kinds of other questions. Waterboard you? I don't know. We don't do that in the United States. That's what they say, just to make people feel better. So my point is, on this type of thing, the 1-month test is a quick, easy, inexpensive test. If a company's going to have some sort of drug policy, they're going to offer the inexpensive test. The company or the business or the corporation that is run by money that the federal government has, they're going to give you a really expensive test. Now, let's say you're able to say no on this thing and you pass the polygraph. Well, then they're drawing blood and they're testing for anything that is illegal in your system. And they're going to pull you in and say, hey, I noticed that 7 years ago, you chose to do this drug.
How do they know 7 years ago precisely?
Great question. Okay, so you agree? You agree that this number is a teeny tiny itsy bitsy number? Agreed? So here we go. I'm just saying. I'm just telling you. So basically, that number right there is this number right here on the graph. Okay? So now you have this horizontal line that you're going to draw along here. And you can track that back. And they can see. They know what most doses are. Like they're going to say, okay, it looks like anywhere from, in this case, probably 7 to 10 years ago, this is what was ingested. Oh, yeah. There was that time. So, can you escape your past? Well, 1 month ago, yeah. Can you escape your past 4 months ago? Probably. Because time is on your side. You got this guy that's talking about 84 months out since you made a choice. I don't know. Depends. Yeah.
Out of curiosity, what if you're like, you turn 25 and you go to like a pawn shop in Colorado, so it's like legal.
Oh.
And then 7 years later they go and they're like, they detected it. But it was like legal.
It's a great. Okay. Here's a great answer for you. Is marijuana legal in the United States? It's federally illegal. Yes? No. I'm just saying. It is a federal law. That's why they keep busting people on the interstates and in the national parks. Because what is an interstate funded by? The federal government. What's a national park funded by? The federal government. So people go up there to Rocky Mountain National Forest saying, dude, we're in Colorado. Yeah, there was this place as we drove in. And here comes the park ranger and says, you can't do that in this park, but it's illegal in the state. But the thing is that the land that you're on is federal land. It's not the state. So the state can't make a law that supersedes the federal government. It's like this. Here's kind of a silly thing. Do y'all have kind of a curfew, or was that like so many years ago? So let's say when you were 15, you had a curfew, yes? Could your parents give you a curfew that was past what the state curfew was? They could, right? What's the state curfew? Let's say it's midnight. Is it midnight? Midnight? 11? 11? Okay, let's go with 11. Let's go with 11. Let's go at 11 o'clock at night. Okay, shh. Hey, we'll finish it. Let's fold this up real quick. Let's say it's 11 o'clock curfew, and your parents say come home at 1. So you're at 12:55, still 6 miles from home. So you decide to push the gas pedal a little further to the floor. You still with me on the story?
Yeah.
Then you got Johnny Law that comes up behind you with the red and blues. They pull you over. Now they got you for speeding. And the police officer's looking at your driver's license saying, you're supposed to be home by 11. He's going to write you, or she's also going to write you a ticket for curfew, and your excuse can't be, well, my parents said it was okay, I was out this late. Your parents can't supersede what the law is. The state can't supersede what the Federal is. Friends, I'll see you tomorrow.
Thank you.
Have a great one. Did you get done? Hang on, let me stop recording.